Hi and welcome to the fifth installment of the Functions and Relations revision. First question we have here, state the coordinates of the centre and the length of the radius for the following circle graphs. First one, we have a translation in the x direction only, so the -2 means it gets shifted to the right by 2. And there's no bracket with the y, so it is going to be sitting on the x-axis. So in this case the centre will be at 2 and 0. And the length of radius, we take the square root of the answer. So the radius will be equal to square root of 9 is 3. Next one won't be quite as easy. We're going to have to complete the square with this one, so we'll need to separate things up a little bit. So I'm going to rearrange this equation. X squared plus 8x, and in a different colour I'll get the y components. So it'll be plus y squared plus 16y. That's all equal to 0. We need to complete the square, so the way that we complete the square is we get the coefficient middle term. So with the x's it's going to be 8 and we divide that by 2. 8 divided by 2 is 4. So this will end up being x squared plus 8x plus 4 squared minus 4 squared. So whatever we add we have to subtract as well, or you can go by adding it to the other side instead of subtracting it on the left hand side. Doesn't matter which way you do it. Plus y squared plus 16y, and again we get the y coefficient, we divide that by 2. 16 divided by 2 is 8, so we go plus 8 squared, take away 8 squared, and this will be equal to 0. Next what we do is take the x components, and the first 3 bits here make up the perfect square. So this will be x plus 4 all squared. And then I'm going to go straight to the bracket for the y component. Plus, we take the first 3 terms there, that becomes the perfect square. Y plus 8 all squared. And then these other bits that we've got left hanging over, take away 4 squared and the take away 8 squared. This is all equal to 0. Now what we need to do is to combine these two terms here. So the 4 squared is 16. So we take 16 and then take away 8 squared is 64. Which this becomes take away 16, take 64 is take away 80. So that's just a little bit of working out there, so let me just shrink this a little bit. Didn't want to shift it all. I wanted to take this bit here and shrink it a bit like that. So what I'll now do is pick a different colour. Try green. So I'll rewrite the whole equation. X plus 4. Oops, that doesn't look like a plus, does it? Do that again. X plus 4 squared plus y plus 8 squared, take away 80 is equal to 0, or that would then mean, if I can shrink it again, I should have shrunk it a bit further. how small I can make it so you can still read it. And if we add 80 to both sides, we get x plus 4 squared plus y plus 8 squared equals 80. So for the centre of this graph, the x coordinates will be shifted to the left by 4, and the y coordinate will be shifted up by 8. So the centre for this one will be at negative 4, and no, that doesn't get shifted up, my mistake. Go the opposite direction. If it's plus, we go downwards. It goes down by 8, so it'll be negative 4 and negative 8. Let me rewrite that one again. Love this little stylus when it works. Negative 8, it's better. And the radius is equal to the square root of 80. Now, the square root of 80, what we need to do is to work out what that's going to be as a simplified surd. Now, when I look at the 80, I know that 80 is equal to 4 times 20, with 4 being a perfect square, and that 20 is equal to 4 times 5, with 4 being another perfect square, but I've already said 4 twice there, so that's 4 times 5, which is 16 times 5. So the radius is equal to the square root of 80, which is the square root of 16 times 5, which is, the square root of 16 is 4. We leave the root 5 as a surd. So that's what it would be as an exact answer. Now let's move on to the next question. Sketch the graph of y equals 2 take away x plus 3. Okay, very quickly, a graph of, pick a blue colour. If I was to draw a graph of just root 2 minus x, that would look a bit like that, which it would start off at 2, and when x is equal to 0, this intercept here would be the square root of 3. So for the graph we're looking at, by the time we add 3 to it, it's got to shift the whole thing up by 3. So the graph that we're going to be looking at here, yes, it will start at 2, and it gets shifted up by 3. So if we have a coordinate of 3 there, that'll give us our starting point, and it'll go up like so. If you're unsure of what the shape of the graph is going to be, you could plot a few points. So you could have plotted 2 to start with, and you certainly would plot the the y-intercept. I'll label these while I'm at it. To calculate the y-intercept, you make x equal to 0. So y would be equal to root 2 take 0, because x is equal to 0, plus 3. 2 take 0 is just root 2, so root 2 plus 3. And you leave it in surd form, so that coordinate there at the y-intercept is 0 and root 2 plus 3. Okay, and you could have plotted, say, x is equal to -1, x equals -2, and you could get a few more points that way if you're really unsure of what the shape of the graph is going to be. And you're thinking, well, where did that starting point of 2 come from in the x-axis? Like what I did up here, you just get that 2 minus x equals 0. And rearrange it so that x is equal to 2. That's where that one comes from. You can, I will now move. Sketch the graph of 4 over x minus 2 squared minus 2. So again, what I need to do is I'll identify this bit down the bottom here, and I'm going to set the x minus 2 squared bit and make that equal to 0. Square root both sides, you've got x minus 2 is equal to 0 because the square root is 0, 0. Add 2 to both sides, x will equal 2. That's going to be significant because if x is equal to 2, that would mean that the denominator here will be 0, which it's not allowed to be. You can't divide by 0. So that tells us that when we draw the graph, that we're going to have an asymptote at x equal to 2. So I'll get a different, yeah, that one I might get a different colour. So there's going to be an asymptote at x equal to 2. And the graph has been shifted down by 2 as well, so that tells us that we'll also have another asymptote at y equal to negative 2. So that one will come through around about here somewhere. That's at negative 2. Now, for the shape of the graph, what's it got to equal? We could start off by finding a couple of the intercepts. So I'll go back to my little working out colour. That'll do. So to work out the x-intercept for the graph, what's that doing there? The x-intercept for the graph, you make y equal to 0 and take our function, so 4 over x minus 2 squared, take away 2 equals 0, add 2 to both sides, so I get 4 over x minus 2 squared equals 2. That's a squared there. I'm going to multiply both sides by the x minus 2 squared, so we get 4 equals 2 x minus 2 squared. Divide both sides by 2, which will get rid of that 2 in the front there. Cancel that down, so 4 divided by 2 is 2 equals x minus 2 squared. Now if we square root both sides, we end up with the root 2 equals x minus 2. Then I'll add 2 to both sides. And this is where I can move it up a little bit, because we know we're sketching that graph. And x-intercept will be at 2 plus root 2. Okay. And then similarly for the y-intercept, I'll do that one in a different colour here. For the y-intercept, we make x equal to 0. So for our function, y will equal 4 over 0 minus 2 is negative 2 squared. Take away 2, which will be equal to negative 2 squared is 4. So 4 divided by 4 is 1. 1 take away 2 is negative 1. So that tells us that we'll have a y-intercept at negative 1, and that we'll also have an x-intercept at 2 plus or minus root 2, that should be. When we take the square root, that should be plus or minus. So that's plus or minus root 2 over there. So we'll have two x-intercepts in this case. One of them being at 2 plus root 2. Doesn't really look like a 2. That's better. And we'll have another one over here at 2 minus root 2. You can get an idea of the size of them if you remember that root 2, and you just have to remember this. Root 2 is around about 1.4, so 2 take away 1.4 is around about 0.6. Okay, so you could have 0.6, and the other one, 2 plus root 2, would be around about 3.4, roughly. So now what we need to do is to actually sketch this graph. And the graph is going to, as it heads more negative in the x direction, it will approach that asymptote of y equals negative 2. And it'll come through, pass through our intercepts that we've organised here, and I've had to drop my stylus so I've lost the line, and then it'll approach that asymptote as it goes up. And being a squared x squared graph, excuse me, y will be in the same direction, so that asymptote of x equal to 2 will basically become a mirror, and the graph will come down like so. And again, if you're unsure of the graph, pick a few other points and just plot a couple of extra points. So you could have, say, picked a point of x equals 1 and x equals 3 and x equals negative 1 and x equals 5, and you could have even picked things like 2.5 and 1.5, which are getting close to that asymptote at x is equal to 2. So that's the shape of that graph there. Let's move on to the next question. Sketch the graph of 6 over 1 minus x plus 3. So again, we need to identify our asymptotes that we have. Look at the bottom here. What's going to make that 0? 1 minus x equal to 1 would be where the bottom would equal 0 there, which we can't have, so we're going to have an asymptote at x equal 1, and there will be a corresponding one at y equal to 3. So if we wanted to draw some axes for our graph, and we'll have an asymptote at x equal to 1, about there. I've labelled my scale, and another asymptote at y equal 3. I think my y scale might be a little bit different to my x scale, but it's not bad. So I have an asymptote coming through there, y is equal to 3. Again, we're going to work out a few core intercepts. So if we want to find out our x-intercept, we make y equal to 0. So we'll have 6 over 1 minus x plus 3 equals 0. Take 3 from both sides. 6 over 1 take x equals negative 3. I'm going to put the bottom in a bracket and multiply both sides by that bracket, which will shift it to the right hand side, which will tell us that 6 is equal to negative 3 by 1 take x. Then I'll divide both sides by negative 3 to cancel that down. So 6 divided by negative 3 is negative 2, will be equal to 1 take x. If I subtract 1 from both sides, we get negative 3 equals negative x. Multiply both sides by negative 1, that gives us 3 will be equal to x. So that tells us that on the x-axis, at x is equal to 3, we will have an intercept there. And similarly for our y-intercept, we set x equal to 0. So for the y-intercept, we make x equal to 0. So y will be equal to 6 over 1 take away x. X is equal to 0, so that's just 1 plus 3. 6 plus 3 is equal to 9. So that tells us that on our y scale, it'll be up here somewhere. At 9 is where we'll have a y-intercept. Now for the shape of this graph, it's going to come in here and get higher, curve around and approach the vertical asymptote, and then it's going to start very low and then it'll come up, cross over 3 and go around like so. Okay, and that's the shape of that graph. Let's move on to the next question. Well, before we do that, again, if you're unsure about the shape of the graph, you could pick a few other x values. So you could have, say, picked x equal to 2 and calculated a point. You could pick x equal to 4 and calculate a point. You could pick x equal to -1, calculate a point. You could pick x equal to -2 and calculate a point. You can even go to things like picking x equal 0.5 and calculate a point up there, and 1.5 and find a point down there. Okay, so if you're unsure of the shape, plot a few points, but the more of these graphs you do, the more familiar you will become with the shape. Now let's move on to the next question. What is the equation of a circle with a centre of 2, -1 and a radius of 6? So the x-coordinate, it tells us that we're going to be x plus something to get it to -2. So if we say x is equal to 2, rearrange that to make it equal to 0, that'll be x minus 2 equals 0. Do the same thing with the y-axis, so the y part of the circle. X equals -1, we want to make it equal to 0, so we'll add 1 to both sides. Y plus 1 will equal 0. And that'll tell us with our graph that we have x minus 2 squared plus y plus 1 squared. And that will equal, we take our radius and we square it. So 6 squared is equal to 36. And that's the answer to that question. Wish they were all that easy. And this will be the last of the questions that we have in this particular screencast. And to give you an idea of what this sort of thing is going to be, I will rearrange it and put it into the circle graph form, because you might be able to identify that a bit easier. So we've got y is equal to the negative square root of 4 take away x plus 1 all squared. Square both sides, we get y squared is equal to 4 take away x plus 1 squared. Now we've got a negative, where did the negative go to? When we squared it, negative times negative becomes a positive. Now I'm going to add that bracket, so we'll end up with x plus 1 squared plus y squared equals 4. So this will tell us we have a circle graph which is shifted to the left by 1, and vertically it doesn't get shifted up or down. It will have a radius of square root of 4, which is 2. So we can now start to sketch what this will look like. x and y at the centre is at x equals -1, has a radius of 2, so it will come through to -3, and -1 plus 2 will take us to +1. So the graph will be, it's the negative half of the circle, so I better make sure I do it the right way. Like so. I was nearly going to go up. Better rub that bit out. Hide my mistake, it never happened. Okay. And it's always good to label the intercepts. We've already labelled the x-intercepts. So if we want to label those in coordinate form, this will be at -3 and 0. And this one will be at 1 and 0. And now to work out what our y-intercept is going to be. For the y-intercept, you always make x equal to 0. So y will be equal to -√of 4 take away. X is equal to 0, so this is just going to be 1 squared. So that will be equal to the -√of 4 take away 1 is 3. So that tells us that our coordinate there will be x is 0 and y is equal to -√3. And that's that graph sketched.